uploaded. So here we go. Complementary supplementary angles. Very simple. Very simple. Complementary adds to 90. If things are complementary, if we have complementary angles, we are talking about angles that add to 90 degrees. Okay? Complementary adds to 90. Anybody remember supplementary? There you go, exactly. So adds to 180, okay? Hey guys, like I said, that's very basic stuff, very fundamental stuff, things that we obviously need to know, associating those words with those measurements. Complementary 90, supplementary 180, okay? And so as we kind of move forward, once we get into parallel lines with transversals, some of these types of things are going to show back up. That's why I thought, hey, let's start right here. Let's make sure we're good with complementary, supplementary, and kind of handle those types of angles before we kind of move on. So this is the kind of stuff you're going to see on the sheet today, okay? Going to start dealing with some visuals, some figures, so to speak, different types of lines. But again, with something like this, and if you want to copy that down, great. But again, noticing, like right there, what kind of an angle have we got there? Do I? Acute. The little square right there. It's a right angle. So we're definitely talking about two lines that form a 90-degree angle. Okay. We've got another line coming out of what we call the vertex there. Okay, without getting into a big terminology discussion here, but that's going to be the vertex. That's where lines kind of, the starting point, the origination point of a line would be a vertex, or where two lines meet would be a vertex. What's that? Pardon? They're all stolen, Cooper. I'm sorry. They've all been hijacked. Sorry, big guy. We've got a line coming out of here that's going to separate that 90-degree angle into two different angles. We know the 36-degree angle. Gee, how do you think we're going to find the missing angle? 90. That's right. We're simply going to take 90 degrees. We're going to subtract off the 36 for a grand total of? What's going to be that missing angle? 54 degrees. There you go. All good. Okay. Again, very basic example, right? We know two angles we've got to add to 90 degrees. These angles are complementary. We know one angle. We're going to subtract that known angle from 90 degrees. Boom. 54 degrees. That's your missing angle. Okay. Like I said, very simple, basic example. Everybody okay with that? Everybody good? Simple stuff. Likewise, now that particular line that I've kind of got the blue brace underneath there, we're going to call that a straight angle. What do you think the degree measurement of a straight angle is? 180 degrees. There you go. 180 degrees. Okay, so just talking about a nice straight line, a nice flat line. Nice straight line is going to be 180. Of course, we've got another line coming from that line at a vertex point here that's going to separate us into two different angles. We have the known angle of 145. How do you think we're going to find the missing angle? That's right. We're going to take 180 degrees, which is our complete straight angle. We're going to subtract off the known portion. So 180 minus 45. And that is a 35 degree angle right there. Basic stuff. So far, so good? Any question? Okay. All right, let's go here. Now, some of these angle measures, very similar to the first example that we saw. We've got a right angle. We've got a couple of lines that form a 90-degree angle, so we are complementary here. Okay, we've got another line that's cutting that 90-degree angle at some point. We've got a 22-degree angle. We have another angle measure that is represented by the expression 4x. Okay, so now here comes a little bit of that algebra rolling into that geometry. All right, there's a couple ways we can do this. Okay, I'm going to show you kind of both ways. You decide what you like better or what works best for you, and you'll kind of figure that out. But one thing that we can do, we know that both angles have to add to what? 90 degrees. So we have a 22-degree angle plus another angle that is represented by 4x. Those two need to equal 90. So we can look at it that way and say, hey, both angles have to add to 90. I'm going to take both angles that I know, one of them being an algebraic expression. I'm going to add them together, set it equal to 90. I create a small equation. What would we do first here to start solving this for x? Absolutely. Let's subtract 22 from both sides. Let's see, 90 minus 22 would be what? 68. And then how would we solve? Divide by 4. And I believe that gives us 17. Pretty straightforward. Okay? And I think, and guys, with a lot of this stuff, make sure that you're reading directions. Make sure you are finding what they want you to find, okay? Are they wanting you to find x? Okay, go find x. Are they wanting you to ultimately find the angle measure, okay? The other way that we could do this, and it kind of depends on how you look at it, is you might look at this and go, you know what? If this angle right here, if we've got an angle that's 22 degrees here, this angle is 90 minus 22, right? Which is 68. And so you might look at that and go, you know what? I'm just going to take 4x and I'm going to set it equal to 68 degrees. 4x represents that angle measure. I know that angle's got to be 68 degrees. So I'm just going to take 4x equals 68, divide by 4. I'm still obviously going to get 17, but maybe you want to take that route. Okay? Obviously, either way is a valid way of kind of attacking it. But where one person might go, you know what, I'm just going to add both things together, set it equal to 90. They're complementary. Boom, I can get it that way. Or I'm going to find out what that missing angle measure is, and I will just set 4x equal to that and go get it that way. Okay? Either way, however you want to do it. Everybody good? Questions? Next. Let's take a gander here. Okay? So obviously this time we've got a straight angle, okay, that's been kind of divvied up via another segment here. A ray, if you will. We start throwing out some terminology there. These things will have arrows on them. But that would be a ray, okay. That's a line. This line got an end point on it, but extends in one direction forever. So we're talking about a ray. So, you're welcome. So here, again, guys, we've got two angles that are going to have to add to what? 180. We've got a straight angle. We've got a straight line that's been divvied up here. We've got a couple angles that are going to have to total 180. So again, we're kind of back to what we saw in the previous example of going, you know what? Do you want to add all this up and set it equal to 180? Do we want to find the missing angle measure? What is this angle going to have to equal? And then I can just set it equal to x minus 5. Again, does not matter. Okay? What would this angle need to be? If this angle's 29, what is this bigger angle going to be? What would that be? 180 minus 29? 151. So you're talking about an angle measure here that's 151 degrees. So we can take x minus 5, because that's what's representing this angle, and we're going to set it equal to 151. Pretty simple solve, right? What's the one step here? How do we solve for x? Subtract or add 5. There you go. Let's add 5 to both sides. X equals 156. Okay? Yes. Oh, I'm sorry, up here? 180 minus 29. That's how we found that angle measure there. And that would be an obtuse angle, right? There's some more of that terminology. Obtuse, greater than 90. Acute, less than 90. Guys, and one thing you kind of start learning about some of this stuff is we equate solving an equation for the answer per se. We know that that angle measure is 151 degrees. Well, x is equal to 156. So a lot of times, just because you solve for a variable, that may not be the answer they're looking for. If they want to know the angle measure here, the angle measure that we don't know is 151. The value of x is 156. Okay? So again, make sure that we're reading directions, make sure we're solving for what they want, okay? And we're getting them what they need. Do they want to know what the variable is? Do they want to know the angle measure? What do they want to know? Let's make sure we give it to them. A lot of times you've got to find the variable to get the answer. All right, here we go. Last couple. Little bit more going on with this drawing here, okay? I tried to replicate a couple things that you were going to see today. Now this time, again, the two angles that are in question here look like they do form a 90-degree angle. So we've got two angles that are going to be complementary, okay? Both angle measures are represented by expressions. We've got a 3x plus 2, and we've got another angle measure that's represented by x plus 4. Now this time, we don't know either angle measure. So what do you think we're going to do with these two expressions? What are we going to do here? Do I? What'd you say? Now, both angle measures are going to have to add to what? Both of them have to add to? 90 degrees. Okay? So we've got this 90-degree angle here. Both angles are going to have to add to give me 90 because they are complementary. So with this particular example, we're going to have to go 3x plus 2, that angle measure, plus x plus 4 equals 90. So we're going to take both angle measures, which are represented by binomials, set them equal to 90. The good news here, even though I've still got things in parentheses, there's nothing to distribute here. We have no multipliers. So really, we could essentially drop the parentheses, On the left side, which terms are like? What can I combine on this left side? The 2 and the 4 for a total of what? 6. And what else can I combine? 3x and 1x, which would be 4x. So we take that left side, we take those two, quote, angle measures, we collect like terms, make them more simple. 4x plus 6 equals 90. Guys, now we're just equation solving. Two-step equation. What would you do next? Yeah, let's subtract 6. So 4x equals, what is that, 84. And final step to solve? Divide by 4. X equals, what is that, 21? Everybody okay with that? Now, if they want you to find x here, we found it. 21 is 21 an angle measure. Is 21 one of the angles?
Yeah.
Now, notice what 21 is equal to. 21 is equal to x. Are either one of these angles represented by just x or not? Okay? So again, good example here of going, okay, what do you want me to find? If you want me to find x, I got you. X equals 21. If the directions say, look, hey, find both angles, you're going to have to take 21. How would you find the actual angle measures? What would you do with this 21? Exactly. We're going to take this 21 and we're going to go put it right there for x and right there for x. Right here, what's 3 times 21? 63?
Yeah.
And what's 63 plus 2? 65. That's a 65-degree angle measure right there. The other one better be 25, right? And if we take 21 and put it here, what's 21 plus 4? 25. Okay? But I would almost guarantee that if a problem like this was on like a multiple choice type test and they said, hey, you know, what's the angle measure of angle whatever, 21's probably going to be a choice because they know, hey, I solved an equation. That must be the answer. Well, it is x, but it may not answer the question. If you want to find the angle measures, take that x, go plug it into those expressions for x, go find those angle measures. Okay, so it just depends on what they're asking for. Okay? Everybody okay with that? Any questions about that? All right, last one. Let's do one that's supplementary here. So, again, just a different type of picture. You're going to run into all kinds of different lines and segments and all that kind of stuff. But I think with this one, I think it's pretty evident that we're dealing with a straight line, a straight angle, if you will. So these two angles are going to be supplementary. They are going to have to add to 180. And so just like the approach that we just took in the previous problem, both angle measures are represented by algebraic expressions, a couple of binomials. So same approach. 4x plus 2 plus 2x plus 22 equals 180. Nothing to distribute. So really, essentially, we can go ahead and collect like terms on the left if you want. 4x plus 2x would be 6x. 4x plus 2x, 6x. 2 plus 22, 24. equals 180. So again, it comes down to equation solving. We build an equation. Now we're just solving the equation. We collect like terms. Who's leaving now? Which one? Minus 24. Let's see, 180 minus 20, 160, 4 more, so 156. 156. And divide by 6. Everybody good with that? Divide by 6. Let's see, that would be 12, 36, 26. X equals 26. So again, depends on what they ask you for. If they want to know what X is, what's the unknown? 26. But 26 isn't necessarily one of the angle measures, right? The angle measures are represented by these expressions that do contain X. You want the angle measures? Take 26. Go run them up there for one of those. Let's see, if we put it here, what's 2 times 26? What is that, 52? And 52 and 22 be what, 74? So it looks like that angle right there would be 74 degrees. If we wanted to know that angle measure, take the 26. 26 times 2 plus 22, 74. And once we know one angle, what would we subtract 74 from? 180. So 180 minus 74, what's that going to be? 106. And 26 and 4, what is that? 106, 104, 5, 6. Yep, be 106. There you go. What do you think? Not too bad, okay? Like I said, just kind of start getting used to looking at these different lines, the way we've got to kind of, separate it out. Where are the angle measures? What are the angle measures? Am I dealing with complementary? Am I dealing with supplementary? Most of them are pretty easy, kind of like those first few examples. You do get into some a little bit later that are kind of like this, where the angle measures are represented by expressions. But, guys, pretty straightforward. But these are basic things that you're going to need to be familiar with and be able to do pretty efficiently. Okay? Any questions? Well, fantastic.